Welcome back. Welcome to the second lesson of a permanent chemical change. Remember, we are still talking about the effects of heat on substances. So in the previous lesson, we have talked about copper 2 nitrate, and we have been able to write the word equation for copper 2 nitrate when subjected to heat. Now, right now, I want us to use potassium permanganate. What happens when we heat potassium permanganate, right? At the back of your mind, you already know that potassium permanganate is a compound. What do we mean by a compound? A compound means it's made up of elements that are chemically combined in it. Now, when we strongly heat potassium permanganate, it breaks down to form three substances. I want you to store this in your long-term memory. When we heat potassium permanganate, it breaks down to form three substances. And the name of these three substances, the first one is manganese 4 oxide. And this is black in color. Black in color. And the second substance formed after the breaking down of potassium manganate 7 is potassium permanganate 6. This one. It is green in color. Then the last substance formed when potassium permanganate is heated is oxygen. This is colorless in color. Remember, I always insist on this. When we come to demonstrating a change, what you need to know is the color of these substances we are using to demonstrate these type of changes. The colors are very important, right? Then you also need to know the substances that are formed, the color before heating and the color of the products obtained after heating. Now, let me say this. Potassium permanganate, this one, it is purple in color. It's purple in color. Potassium permanganate or potassium manganate 7 is purple in color. Now, when you heat a purple potassium permanganate or purple potassium manganate 7, it breaks down to form a green-black substance and a colorless gas. Let me repeat this. When you heat potassium manganate 7, it breaks down to form a green-black substances and a colorless gas. A green-black substance is a mixture of manganese 4 oxide and potassium manganate 7. Right. Let me take you back. Let me emphasize this. When you heat potassium manganate 7, which is purple in color, it breaks down to form a black-green substance and a colorless gas. A black-green substance is a mixture of manganese 4 oxide, which is black in color, and potassium permanganate 6, which is green in color. And of course, the gas produced, which is colorless, is oxygen. Now, allow me to write the word equation for this to represent the effect of heat on potassium permanganate. Word equation. So let me write potassium permanganate potassium. Let me use manganate 7. Manganate 7. It's not 7. Potassium manganate 7 then arrow here to indicate you are heating. Like a hapo heat. What do you get? You get potassium, manganate, manganate 6 plus manganese 4 oxide plus oxygen. Remember I said when you are writing word equation, don't forget to write the colors of this substance to indicate the colors. So this is purple. This is purple in color. This is purple in color. Then this is green in color. Then this is black in color. Then of course oxygen is colorless. Then of course oxygen is colorless. Just to emphasize, when we hit potassium manganate 7, which is purple in color, it breaks down to form potassium manganate 6, which is green in color, and manganese 4 oxide, which is black in color, and oxygen, which is colorless. Right. An examiner might be tempted to trick you and said a certain learner was in the laboratory heating a purple substance. Then during heating, the learner realized that a purple substance formed a green-black substance, and a colorless gas was produced during heating. Then the examiner asked you, give the identity of a purple substance, give the identity of a green-black substance, and give the identity of a colorless gas. Identity means you give the name of that substance. Now, if we happen to ask you to give the identity of a purple substance, that is potassium manganate 7. If examiner asks you to give the identity of green-black substance, just tell him or her that is a mixture of potassium manganate 7 and manganese 4 oxide. Then if you are asked to give the colorless gas, tell the examiner this is oxygen. Right. Now, I want us to look at the characteristics. You're already done with this. We have been able to write the word equation for copper 2 nitrate, also the word equation for potassium manganate 7 or potassium permanganate. Now I want us to look at the characteristics of permanent chemical change. Of permanent chemical change. What are the sum of the characteristics of a permanent chemical change? Now, I want to take you back to the equation which we are having here. This one for potassium manganate 7. Then, I need you to ask yourself, is it possible to get potassium manganate 7 from these 3 products? Is it possible to get potassium manganate 7 from potassium manganate 6 and manganese 4 oxide and oxygen? In a simple term, I need you to ask yourself this question. Is it possible to recover potassium manganate 7 after heating? The answer is no. Right? Now, the first characteristic of a permanent chemical change is the change is irreversible. The change is irreversible. Irreversible means we cannot be able to recover or to reverse the change. To reverse the change or to recover the original product which we had before heating. So the change is reversible. Then the second question which I want you to ask yourself. Initially, we are having potassium permanganate. Then the products, we are having 3 products. So ask yourself, is there formation of new substance or new substances? Or there's no formation of new substance for this case? According to what we have here, there is formation of new substances. Potassium manganate 7 is a new substance. Manganese 4 oxide is a new substance. Oxygen is a new substance. The characteristic number 2, we therefore say there is formation of new substances. There is formation of new substances. So the first one, the change is reversible. There is formation of new substances. Now, I want you to ask yourself the third question. Is there a change in mass before and after? The answer is yes. If you weigh the mass of potassium permanganate before heating and you weigh the mass of the products after heating, you will discover that the mass of the products formed after heating will be less than the mass of potassium manganate. So there is change. There is change in mass. Then the last one, the change is accompanied by net heat change. So the change is accompanied by net heat change. What do we mean here? The heat is either released in the environment or the heat is either absorbed from the environment. The heat is either released to the environment or absorbed from the environment. Just a quick summary. Characteristics of a permanent chemical change. The change is irreversible. 2, there is formation of a new substance or new substances. 3, there is change in mass. Then the change is accompanied by net heat change. And for this we can say the heat is either released or absorbed from the environment. Now allow me to talk about the last part here, this one. Examples of chemical changes in real life. Number 1, we have rusting. Rusting, that is a chemical change. Digestion, that is a chemical change. Burning of papers, that's a chemical change. Burning of papers. Burning of wood. So these are examples of chemical changes in real life. So we have rusting, digestion, burning of papers, burning of woods, and more examples. So you can add more examples here, right? So thank you very much for your time. Thank you because I believe you're going to like this video, to subscribe, as well as to share with your friends in various schools.